Hello everyone. Our project name is Intelligent Fruit and Vegetable for Agriculture and Food Industry. Here we provide our project objectives. First of all, the objective is to develop an AI-based system for accurate and rapid identification of various fruit and vegetables. Second, it is to improve the efficiency of produce sorting and inventory management in the agriculture and food industry. Third, it is to enhance the capabilities of automated sorting and packaging systems. Next, it is to manage stock in supermarkets and food distribution center efficiently. Lastly, the objective is to identify fruit and vegetable is critical for efficiency, inventory management and sorting accurately. So basically, the development of AI-based system for identification of fruit and vegetable is to aim significantly enhance efficiency in agriculture and food industry process by improving sorting accuracy and inventory management. This technology contributes to streamline operations, particularly in supermarkets and food distribution center because it will optimizing the overall supply chain.
For our proposed model, we started with collecting dataset of images containing vegetables and fruits including various species and variations through online. Next, we importing the dataset, imaging a dataset filled with images and various fruits and vegetables. Using Python and TensorFlow, we import the dataset, making sure it's well organized into training and validation sets. Next, we split our dataset into training and validation sets. This ensures our model learns from one set and validates its performance on another, preventing overfitting. Then, we pre-process our images. This involves normalizing pixel values, sharing, zooming, and flipping to augment our dataset, making sure our model more robust. Then we are building convolution layer. This architecture excels at recognize pattern in images. In TensorFlow, we build our CNN layer. After building our model, we compile it. This involves selecting a loss function, an optimizer, and metrics to track. Then we embark on the training phase. Next, we visualize the training and validation accuracy over epochs using graph. This helps us understand how well our model is learning and if it's overfitting. Finally, we test on our model on a separate testing set to evaluate its real-world performances.
Next, I will explain about the convolutional neural network. CNN. CNN is a subset of machine learning. It is one of the various types of artificial neural network which are used for different applications and data types. CNN is specialized type designed for image processing and pattern recognition. CNN have 3 layers. First, convolutional layers, next, pooling layer, and lastly, the fully connected layer. In this project, we use CNN for building, training, and evaluating. For this project, we also use the TensorFlow and the Keras. TensorFlow is an open source machine learning library. TensorFlow provides a flexible platform for building and deploying machine learning models, including the CNN. Keras is a process source deep learning API written in Python. It is serving as an interface for building neural networks. Keras is very user-friendly syntax and seamless integration with the TensorFlow. The combination of Keras and TensorFlow provides a good accessible environment for designing and training the neural network, including the CNN.
For the first process, the convolution layer will scan each element of the matrix by using the filter and extracting the important feature from the size and the filter and putting it in a separate matrix. For the next process, the pooling process are going to extract the maximum value from the 2x2 matrix and sorting it in a separate matrix by using the filter and max or average as the parameter. This process is to reduce the size of images and focus on important features of the image. Lastly, flattening process, which in the fully connected layer. Two-dimensional matrix convert as input of neural network and passing it to the neural network by defining hidden layer and more hidden layer and then getting the result on output layer.
Assalamualaikum, my name is Salmi. My metric number is 292802. First of all, we are going to go through training code. Here we already mount Drive to import our dataset. This is the code to mount our Google Drive, and here is the path of our Google Drive. So what we have done so far, we have imported all the required library here. We import NumPy, TensorFlow and Matplotlib here. Then let's begin with data pre-processing. We need train data and validation data. Validation data is used for model training. For model training, we need training dataset and validation dataset. For training image pre-processing, we define training set. In training set, we create one class which is tf.keras. We import keras, and in keras we coin in utils, and in utils we coin in image dataset from directory. This is our class. So in this we going to pass a lot of things. First is a path of training set. So this is our training set path. Second is labels. We have to define label as invert because we have label in the form of directory here. These directories are label of the training set. Next is label mode. We define as categorical as we have more than two classes. Class name set as none since our dataset doesn't have flow. It's already in directories. Color mode as RGB. Batch size as 32. Image size as 64 since we do not want to we don't want to go through very details of our image. We only need important parts of the image. If we increase our image size, it's going to take a lot of details in that image and take a lot of time. Next, shuffle, set as true, seed, validation, split and subset as none, interpolation as bilinear because it's just for resizing the image. Then follow, link and group to aspect ratio as false, which we put in default as provided by Keras API. We have completed this training set. So this training set variable will go in this directory, and this directory will modify and everything and restore the result in training set variable. Here found 311 files belonging to 36 classes. So it shows we are successfully have 36 fruit and vegetable and 3115 image. Next, for validation image pre-processing, we set it similarly as training image except for the directory. This is directory for validation dataset. Here showing that found 351 files belonging to 36 classes. So validation set also have 36 classes. So training image pre-processing and validation pre-processing is done. Now we are ready for model building. Then we move to model building. So we define one variable CNN equal to TensorFlow. We use Keras to model, model to sequential. Here we are successfully created our CNN model. Then we create a convolution layer. We use enn.add and we pass TensorFlow to Keras. And in Keras, we interested to layer, and in layer we want to create convolution layer. So we use convolution 1D and 2D. So here we have to pass first parameter as filter, and filter stated as 32 since we tune the model and getting good result on the filter value. Next, kernel size as 3. It is standard kernel size. Next is activation as ReLU, and our input shape we have to take as same as we created at validation image preprocessing. So we have successfully created our convolution layer. Now we interested in create pooling layer. In pooling layer, we are interested in max pool 2D. And here we define pool size as 2 and stride also 2. We are saying that scan 2 cross 2 part and extract the maximum value from 2 cross 2 part. So this is a meaning of this pool size and stride. We have created our first convolution layer and first max pool layer. Then we create one more layer, same thing to do, but here we do not pass this one since we already passed one time. So we resize thing one more time to focus on important features of whatever we are getting from maximum pool. And again we define convolution layer and use this max pool to decrease the size. That's why we do it 2 times, so that we can only focusing on important features. We cannot do it more than 2 times because we might lose some data. Now we have to add one more parameter, cnn.add. Use tf to keras 2 layer to dropout, and dropout use 0.25 and 0.5. This dropout is useful to avoid overfitting. Now we're ready to pass to neural network, but before we need to execute flattening process. So here tf to keras go to layer, go to flatten. So here after executing successfully flatten our matrix to 2 cross 2 matrix. Now we already building our neural network. So cnn.add tf to keras to layer to dense to make a neuron. And in dense, pass unit to 36, and here we pass activation using ReLU activation function. Now after create hidden layer, we need to create output layer. We use cnn.add tf to keras 2 layers to dense. We pass 36 unit. Since we have 36 classes, we need to collect output for 36 classes, and here use activation for softmax. So we already create our output layer.
So for compiling and training part, we use optimizer Adam, which used to adjust the inner parameter to minimize the loss function. For loss, we use categorical cross entropy because data we have more than 2 input, which is 36 class of input. So we use categorical cross entropy. For matrix, we use accuracy to track the accuracy of the given dataset. So this matrix will measure the ratio of correctly predicted observation to the total observation. Next, for this part, we have 3 parameters of cnn.fit. We assign this cnn.fit into the training history variable. So in first parameter, we pass x, and we're gonna use training set. Second, we have validation data parameter, and we're gonna pass validation set. And third, we have epoch. This means how many times that we want to train the process. So we use the 32 epoch. So this is the result of the training process, and we successfully complete the training process. So next we go to evaluating model. So for this part, we want to evaluate the performance of the compiled CNN for both which is training set accuracy and validation set accuracy. So here it will return the training loss and training accuracy, and validation loss and also validation accuracy. Next we go to saving model. For saving model, we just type cnn.save and we save in H5 format. So for the train model, this is a file extension in which the model will receive. Next, for training history.history, it will return the dictionary of history. So after we run, we have loss key, which have 32 values of 32 epochs, and also we have accuracy key and validation loss key. So all of this will return the dictionary of history. So for this part, we record the history in JSON file. So we import JSON with open training his.json with SF for the file. So for the JSON dump, we call the training history.history that we already get from above. So we want to explore what training history.history about. So we just type print training history.history.key.
Now we are visualizing our training accuracy and validation accuracy. In accuracy visualization, we want to do training visualization. First, create one list of epoch and list comprehension technique, because in X-axis we need number of epochs, and that's why we create a list that having the values 1 until 30. So we write as I in range 133. Now we have to pass the accuracy, use PLT because of just now in importing libraries we use the import matplotlib.pyplot as PLT. In X-axis we need to pass the epoch list 1 to 30. In Y-axis we need to pass the training history.history that will give the training accuracy and on all 30 epochs. And we use the color rate for the graph. After we run this, we get the 30 epochs and the red graph is the training accuracy. We plot all these 30 epochs on both axes. This 30 is the number of epochs and this is the corresponding accuracy of training set. We label this plot as plt.xlabel, the x-axis as the number of epochs, and the PLT-Y label the y-axis as the training accuracy. The PLT.title is the title of this plot, which is visualization of training accuracy result. Similarly, we have to repeat for the visualization of validation accuracy. Create here text entry validation accuracy. We already have this epoch. We don't need to create new. Just write plt.plot and use this epoch. The second parameter, that is this one x-axis of this plot, and y-axis we need the training history.history, and use the val accuracy because val accuracy consists of 30 epochs validation set values. And for the graph we use the blue color, and this the accuracy of validation set. It's almost above more than 0.8. We label the x-axis number of epochs and the y-axis is validation accuracy. The title is visualization of validation accuracy result. So we have successfully done the visualization of validation accuracy.
Next, let's move to the testing part. Our goal was to create a model capable of identifying various fruits and vegetables from image. So in this testing code, we use TensorFlow and Streamlit. This project involved a dataset containing image of fruits and vegetables. The dataset was already categorized to train the deep learning model. In this code, we uploaded the model TensorFlow from the training code, which is train_model.h5, to analyze the image of fruit and vegetable. At the image prediction, we start by loading our pre-trained TensorFlow model, which is model equal to tf.keras.model.load_model in bracket train_model.h5. When a new image is uploaded, we use tf.keras preprocessing image to convert and prepare it for the analysis. Image preprocessed to a uniform size of 64 multiple by 64 pixels to ensuring the consistency for prediction. We also provided the dashboard for different sections, which is we have 4 sections, which is home page, members page, about project page, and the prediction page. User can upload an image for the prediction at the prediction page and visualize it with a simple click. So let's see how the system works.